let's move on to scientific notation. This is something you guys probably should have done. If you haven't yet, though, don't be too worried. Well, it's not too bad. Right off the bat, let's scroll down a little bit. So operations with scientific notation. I just want to kind of go over what scientific notation is and how to put things into scientific notation. Make sure that we remember that. So let's say you had a number like, I don't know, 2, 6, 4, 0, 0, something like that. And they said, okay, put this in the, you can only write this, let's say, with 3 significant digits. What we'd have to do is we'd have to put this into scientific notation because right now I have 5 significant digits. So what I would do is I'd write this as 2.64. The decimal always comes after the first number. That's the way we like to write it. So 2.64. And then I need to multiply it by 10 to the power of something. And that's scientific notation, right? And the way that you can tell what that something is I had to move the decimal place 1, 2, 3, 4 places. So this would just be 2.64 times 10 to the 4. And that's how you'd put that into scientific notation. And if the units were something, they would just come after. So if this was like, I don't know, meters. So that's how you'd write that. If you had a number like, let's say 0.00298, and I said, okay, we need to write this in scientific notation. Or if I said we need to write this with 3 significant digits, what this would be is I'd look at, it would have to be just containing these numbers, right? So I'd say this is 2.9, that 4 is going to make this round down to just 8 because I want just 3 significant digits. So I kind of drop the 4 in that case. It's not going to be significant anymore. And then I got to figure out I need to multiply this by 10 to the something. And again, all I do is I say, well, I move the decimal place 1, 2, 3 times, and 3 times to the right, if you want to think about it that way. Or you can think about it, I went from a little number, so I need to multiply by 10 to the, something small. So this is, the only difference here is this is going to be times 10 to the negative 3. Right? Okay, so another way, just to make sure that you're clear on this, what times 10 to the negative number means is that really means 1 over 10 to the 3. So what you're really doing here is you're going 2.98 divided by 10 to the power of 3, which makes sense. That would give you a really small number, right? Just so you guys have a bit of a conceptual view of why we write it that way. Okay, so that's how you do scientific notation. I got some questions for you guys at the end to try to work with that. Now, if we are doing operations, so adding or subtracting, multiplying and dividing, we just have a few ways of doing that. So adding and subtracting, when both numbers have the same exponent. If they have the same exponent, like they're both to the power of 8 here, it's easy. All you got to do is actually just add your numbers. So this just becomes 7 times 10, and then just keep the 10 to the 8 the same. Yeah, and I got another example below there. When numbers have unlike exponents, for these ones, you kind of need to have the same exponent, n. Why I said n is because that's the way I've written it up here, n. So what we do is we just take, let's say this number, if I had 3.2 times 10 to the 4, I just turn that into these numbers times 10 to the 5. And the way I do that is if I move this decimal place over 1 to the left, this would become times 10 to the 5. So 0.32 times 10 to the 5, that's the same thing as 3.2 times 10 to the 4. So we turn it into that, and now we can do just like we did above. You just add these two numbers, and that gives you 5.02 times 10 to the 5. But with sig digs, remember, we can't have 3 sig digs because our sig digs were only 2. Actually, in both these cases, there was only 2 sig digs. So okay, so proper sig digs is like that. So multiplying and dividing is actually a little bit easier than adding and subtracting again. We don't have to have the same exponent on these ones. So multiplying and dividing, you can just kind of follow these steps here. It says multiplying and dividing the m parts. And what I mean by the m parts, if you look back on that last page, that was just that original formula for scientific notation. By the m parts, I mean just your numbers, right? So in this case, we just multiply 7.3 times 2.1. That gives you 15.33. So that's step number one. Step number two, if multiplying, then add the end part. So we are multiplying. So what we do after we go is 14 plus, right, because we're adding, plus negative 2. But plus negative 2, that's the same thing as 14 minus 2. So that becomes 12. And then, so we did that. If dividing, you subtract, so that's the one below. Adjust the decimal if necessary. So if you do that, we get 15.33. Like I said before, we like to have it written with a decimal after the first number. So we move that decimal place over one time, so 1.5. And then if I move that to the left once, that becomes to the 13. So 1.5 times 10 to the 13. Okay. Round and record your answer using proper sig digs. So in our answers, we had 7.3 and 2.1. Sorry, in the question. Sig digs of 2. Our answer should have sig digs of 2. Okay, so that's going to be it for scientific notation. I'm going to let you guys go ahead and do the practice problems. So practice problems 1, 2, what was it again? 1 to 12. So do all those practice problems, and I'll make my next video with the answers. It'll be up to your teacher, though, whether you'll get the answers before or after you give them a try. So, all right, I'll see you guys in the next video.